These type of problems require that you understand a few definitions and a few principles. This problem is a good problem as it illustrates all three of the definitions that you need to know to accomplish any of the problems in these sections involving sets. But first, the principles. We always use capital letters like a capital U, capital A, capital B to represent sets of numbers. But the U is special. The U stands for the universal set. The universal set is the set of numbers that define the only numbers that we're considering. So the universal set that we're dealing with here is the number 1, 2, 3, and dot, 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 all the way up to 12 implies 1 through 12. So all of the whole numbers from, or the natural numbers from 1 to 12. So we're working with the numbers from 1 to 12, but then what it does is it defines two other sets which are subsets of the universal set. So set A only contains 2, 3, 5, 6, and 12. Notice all of those are in the universal set, but not all of the numbers in the universal set are in set A. Likewise, set B is a subset of the universal set. It contains the numbers 3, 4, 5, and 7. It doesn't contain all of the numbers from the universal set. It only contains 4 of those numbers, specifically 3, 4, 5, and 7. Okay, so you got this universal set, again, which defines all the numbers we're considering, and then the A and the B are subsets of that universal set. Now over here, we're supposed to determine this following statement. Okay, there's a couple things that we need to do in here. First principle that we need to understand is that we want to work our way inside out when it comes to parentheses. So always do the piece in the parentheses first. Okay? And it's always helpful to perform each of the operations indicated here one at a time. Okay? Now, defining these really quick, that operation right there is union. Okay? Union implies combining everything from both set A and set B. Union, combining both of them. Okay? This stands for intersection. Intersection implies only the items that the two sets have in common. Where do they intersect? Only the items that they have in common. Lastly, you have this little comma right here. Okay. That comma is the not symbol. The not symbol, there's other names for it as well. Textbook, I believe, uses a different name sometimes, but the not symbol simply implies the exact opposite of what is in the set. So whatever the set contains, the not set, when you not the set, you get rid of everything that the set contains and put in whatever the set didn't contain. So let's work through this one piece at a time. Again, principle working from inside out. So we first want to do A union B. A union B. And if you recall, union represents the combination of A and B. So if I combine all of the elements in A with all of the elements in B, let's see, I've got 2, 3, which is in both of them, but I'm only going to keep one of them. I've got 4, 5 is in both, but again, I only keep one. I have 6, 7, and 12. So the set of numbers 2, 3, 4, 5, 6, 7, and 12 represent the union of A and B. It's everything that was in A and everything that was in B combined together. And if there's repeats, you just keep one of them. Okay? Now, That's A union B. That's the piece inside of the parenthesis. However, the parenthesis that A union B is inside has the not symbol on it. What that means is I now need to take A union B and I need to not it. In other words, whatever elements are in A union B, I need to remove them, and whatever elements from the universal set are not in A union B, that's what is now in A union B not. So 1 is not in there, so I include that. I have a 2 here, 3 here, 4, 5, 6, 7, but no 8, no 9, no 10, and no 11. But I do have a 12. So 1, 8, 9, 10, and 11 are the elements from the universal set that weren't in A union B. So I now have A union B not. The last thing I need to do is I need to take that A union B knotted. Okay. I need to take A union B knotted, and I need to find its intersection with B. So A, now I'm going to bring B down here really quick. B, defined up above, is equal to 3, 4, 5, 7. This set 3, 4, 5, 7. Okay, so taking a look at that, I'm supposed to find again the intersection. The intersection is whatever the two sets have in common. I'm finding the intersection of A union B knotted and B. So it's these two that I'm trying to find the overlap. Now you'll notice here that I've got 1, 8, 9, 10, 11 in A union B knotted, and I've got 3, 4, 5, 7 in B. So again, intersection is what do those two sets have in common? Looking at those sets, you can see that they have nothing in common. So the intersection of those two sets is nothing. It's the empty set. It's the set that has nothing in it. Now you'll notice this, it says type N for the empty set. The intersection of A union B knotted and the set B, there is no intersection, there is no overlap. So the correct answer that you would plug in here would be N. Okay. Not what you had done. Now noticing what you had done, 1, 8, 9, 10, 11, you correctly inputted the A union B not. But then that last step of intersection B, okay, it's what do those two have in common? They have nothing in common. So the correct answer again would be N, which represents the empty set.